Step 1. Place the instrument on a sturdy, level platform. Step 2. Connect cables and power on. Connect the power cable, and insert the security dongle into a USB port. Insert the USB hub into a USB port. Plug the mouse and keyboard into the USB hub. Press the computer power button to turn on the screen. Wait for the system to complete its automatic startup detection. The main program interface displays the image display window, particle distribution graph, and channel result table. Step 3. BGD 245 is compatible with a variety of fineness gauges, based on the approximate fineness range of the sample to be tested. Take out the fineness gauge and carefully inspect it to ensure there are no scratches or damage in the groove. Carefully inspect the scraper to ensure there are no nicks, damage, deformation, or any other defects. Rinse the fineness gauge and scraper with alcohol, and dry them with a lint-free cloth or cotton gauze. Thoroughly clean and dry the fineness gauge and scraper with a volatile solvent. Step 4. Open the sample loading area on the left side of the instrument. Place the fineness gauge on the support with the 0 graduation mark facing left. Note: after confirming the platform is free of foreign objects, place the fineness gauge flush against the stop bar on the support. If using a wide groove gauge, remove the stop bar before placing the gauge. Insert the scraper into the scraper fixture. Step 5. Use a spatula to thoroughly mix the sample. Drip several drops of the sample into the deepest part of the groove, allowing it to slightly overflow. Note: avoid introducing air bubbles when adding the sample. Step 6. After clicking the Start button, in the pop-up window, enter the sample batch and name. Click Select Gauge and choose the fineness gauge being used. In the selection menu below, you can click to enable the respective functions. The Rattenf and Hegman methods correspond to the reading methods specified in standards ISO 1524. Scrape operation. Enabling this function activates automatic scrape operation by the instrument. Bubbles as particles, fully transparent emulsion, leave unchecked by default unless under special circumstances. Click the Yes button. The instrument will automatically perform the drawdown and capture an image. Note: do not touch the gauge with your hands during the drawdown process. After scrape is complete, immediately remove the fineness gauge and scraper and clean them carefully with a suitable solvent to avoid sample residue. Note: if the rheological properties of the sample prevent a complete pattern after drawdown, add the minimum amount of a suitable thinner and mix manually. Then repeat the test, and note this in the report. Step 7. After image capture is complete, the captured image is displayed in the image window. Use the mouse wheel to zoom in on the image area to observe particle distribution. The particle distribution chart automatically counts particles within each graduation interval. The results table for Groove 1 displays the readings for Rating and Hegman. Observe where dense particles first appear in the sample. Specifically, the position where a 3 mm wide band across the groove contains 5 to 10 particles. Scattered particles that may appear above this area of dense particles can be ignored. Observing the image captured in this experiment, right image. The first 3 mm wide band containing 5 to 10 particles lies between 25 micrometers and 30 micrometers, and the graduation value for the 100 micrometers gauge is 5 micrometers. Therefore, the method rating reading is 25 micrometers. The Hegman is 6. The reading is consistent with the manual judgment, indicating a normal instrument result. Step 8. Click File Save Image. This saves the captured image for convenient archiving and retrieval. Click File Export PDF. This automatically generates a test report for this experiment. Click Start again, and after entering the routine test information, the test can be repeated. According to test requirements, after performing 3 parallel tests, click File Export Excel. This automatically generates the experimental data table for this test. Calculate the average of the 3 measurements and record the result to the same precision as the initial readings.